Welcome back to the deep dive. If you're like most organizations, you've probably mastered the art of, turning off unused resources. That's the low-hanging fruit. But the next level, the real strategic game, is making sure you're paying the absolute minimum for everything you have to keep running. Today, we are focusing on one of the most powerful and, let's be honest, often most complex capabilities in FinOps, rate optimization. Our mission is to really understand the strategic levers, the deals you negotiate, the architectural choices you make, and of course the commitments that can drastically lower the rate you pay. Okay, let's unpack this.
The whole idea behind rate optimization is beautifully simple on the surface. At its core, your cloud cost is a simple equation, right? It's the amount of a resource you use multiplied by the rate you pay for it.
And most people start by trying to lower the amount.
Exactly.
Yeah.
Turning things off, right-sizing, rate optimization flips that. Here we are laser-focused on driving down that rate using every tool we have, from, big enterprise discounts to really strategic commitment plans.
So it sounds like there are three main levers organizations can pull to attack that rate. And I'm guessing FinOps isn't directly responsible for all of them, but they're involved.
That's spot on. The first one is what we call negotiated discounts. This is the highest level. Think enterprise-level agreements you make directly with your cloud provider.
And that's usually procurement's territory, right? They're the ones signing the big deals.
They are, but the FinOps team provides the ammunition. They're the ones who can walk in with the data.
What kind of data?
They're tracking historical usage, but more importantly, they're projecting future consumption. So procurement can say, look, we're spending X now, but we're about to launch a new product, and we project 40% growth in this database service over the next 2 years.
So FinOps provides the leverage. They turn cloud data into a business case.
Precisely. It gives procurement what they need to demand a better rate.
Okay, so that's lever number one. What's the second?
The second is a bucket of what we call other rate optimizations. These are often more about architecture.
You mean things like choosing a cheaper region to run a workload?
That's a big one. Or deliberately architecting a system to use a service that's just inherently cheaper, like using serverless functions instead of a virtual machine that's on 24/7.
So you're using the provider's own pricing model as a design principle.
Exactly. But while those are important, the third lever, commitment discounts, is really the bread and butter of the FinOps team's daily work. And it's where you see the biggest, most immediate savings.
Okay, so this is reserved instances, savings plans, CUDs, the whole alphabet soup.
Yep. This is where you commit to a certain level of usage or spend over, say, a 1 or 3 year term. And in exchange, you get a really deep published discount.
And I imagine there's a catch.
The catch is always flexibility. The more restrictive the commitment, like a specific machine type in a specific region for 3 years, the higher your discount. The more flexible it is, the lower the discount. Certainty for the provider equals savings for you.
That trade-off is huge. Let's really dig into the two main types of commitments, because I've seen organizations get burned by choosing the wrong one.
It's so easy to get burned. The distinction really dictates your agility. Let's start with the more restrictive one. Resource-based commitments. These are your classic reserved instances, or RIs, and some committed use discounts, CUDs.
And what does resource-based mean in practice?
Think of it like a very specific coupon. It's for a particular item on the menu. So you're buying a discount for, say, an M5 large compute instance in a specific availability zone.
So if I buy that RI and my engineering team then decides to upgrade that instance to an M5.X large.
Your coupon is now useless for that resource. It's vacant. And worse, you're still paying for it.
Ouch. Okay, so what's the alternative?
The alternative is spend-based commitments, which are mostly known as savings plans. These are much more flexible. Here, you're not committing to a specific instance type, but to a certain dollar amount of spend per hour.
So instead of a coupon for a specific coffee, it's like a gift card for the whole coffee shop chain.
That is the perfect analogy. So if your team changes that instance from a large to an X large, or even to a totally different instance family, the discount just moves with the usage.
Right.
As long as you're spending that committed amount on compute, you're covered.
Got it. And this complexity, this is exactly why you can't just let every single engineering team go out and buy their own commitments.
You absolutely cannot.
Yeah.
That brings us to the core commitment strategy. It has to be driven by a central FinOps team. They have the bird's eye view of the entire organization's cloud usage.
And if you don't centralize it, you just get chaos and waste.
You get massive vacancy, which, as we said, is a commitment you're paying for, but nothing is running that it can apply to. It's just lighting money on fire.
Here's where it gets really interesting. because this whole area feels like it's just ripe for conflict inside an organization. You start planning these rate optimizations, and suddenly you're stepping on another team's toes.
The tension is constant, you're right. A great example is with interruptible resources. You might know them as spot instances.
Right, this is the spare capacity the cloud providers sell off for a massive discount, sometimes like, what, 80% off?
Or more.
Yeah.
It's a huge rate optimization. But the trade-off is that the provider can reclaim that instance with just a couple minutes' notice.
Which means your application has to be built to handle that. It can't just crash.
It has to be architected for that kind of failure.
Yeah.
So the FinOps team might bring the idea, hey, we can save 80% here, but they have to work very closely with engineering to see if the architectural work and the risk are actually worth it.
And that leads right into what you call the primary conflict, right? Rate optimization versus workload optimization.
Yes, the classic conflict between paying less for what you have versus changing what you have to be smaller and more efficient.
So on one hand, you have a recommendation to buy a 3-year commitment for a big server. On the other, you have a recommendation to right-size that same server to be half the size.
And this creates two huge problems. First, a financial one. Teams look at both recommendations and they double count the savings. They think they'll save money from the commitment and from the right sizing, but the actions are mutually exclusive.
And the second problem is the operational one, the vacancy risk we talked about.
Exactly. If the finance team buys a 3-year commitment for a large database, and then 2 months later the engineering team finally gets around to right sizing it, you're now stuck paying for a commitment that covers nothing.
It's like buying a year's worth of gasoline for a huge truck that you know you're trading in for an electric car next month.
Perfect analogy. You have to remember, commitment discounts are not the resource. They're just a prepaid long-term coupon. If the resource goes away, the coupon is still there, and so is the bill.
Logically, then, you'd want all the right sizing to happen first, right? Get the footprint as small as possible, and then buy the commitments.
In an ideal world, yes. But optimization can take months, sometimes years. FinOps can't just sit around waiting, losing out on all those potential savings. It's a balancing act. You have to create value now while managing the risk of future changes.
And there's another conflict here, too, around sustainability.
A very important one. If you buy a 3-year commitment for an oversized server that's just idling at 10% CPU, you're not just wasting money. You're locking in unnecessary carbon emissions for 3 years. The goal should be to commit only to the level of resources you actually need.
This is clearly a team sport. It's not just a FinOps job. So who needs to be at the table to make this work?
The FinOps practitioner is the quarterback. They manage the overall strategy, they do the analysis, they oversee the purchases, and they figure out how to allocate the savings back to the teams.
What about the engineers? What's their role?
Engineering's role is non-negotiable. They have to provide forecasts, not just of current usage, but future plans. They have to tell FinOps, hey, we're planning a major refactor of this system in 6 months, so don't buy a 3-year RI on it.
Okay, so you also need finance and procurement.
Right. Finance and procurement work with FinOps to set the guidelines. Finance needs to model the prepayment for these discounts, and procurement handles the top-level negotiations we mentioned earlier.
And leadership's role is just to approve the strategy.
Mostly, yes. Leadership needs to back the centralized purchasing model so that one rogue team can't mess up the strategy for everyone. And even the product team gets involved, helping decide if a non-critical workload can use something risky like Spot to improve its margins.
Let's talk about the maturity journey. Where do organizations start? What does the crawl stage look like?
In the crawl stage, it's very ad hoc. A big bill comes in, someone panics and buys a few RIs. There's no real strategy. Procurement might have a deal, but FinOps isn't really feeding them data. Coverage is low, and Spot is just an experiment.
And then they get to the walk stage.
At the walk stage, things are getting serious. You have an actual strategy. The central FinOps team is reporting on utilization and vacancy. They have a regular purchasing schedule, and they're getting input from engineering. And crucially, they have alerts set up for when utilization drops.
So they can be proactive about waste. What does the ultimate goal, the run stage, look like?
The run stage is highly automated and integrated. The purchasing cycles might be quarterly or even triggered automatically by forecasting models. The allocation of the savings is all automated. And you're not just looking at cost, you're factoring in sustainability and software licensing into your commitment decisions. It's fast, agile, and data-driven.
So the final piece, how do you know if you're actually doing a good job? What are the KPIs for success?
The framework gives us some really clear targets. For those resource-based commitments, your IRIs and CUDs, You should aim for about 80% utilization on your steady-state workloads.
Why not 100%?
Because that 20% buffer gives you room to breathe. It allows for small fluctuations or minor right-sizing without immediately creating waste.
Okay, and what about the flexible spend-based plans?
For savings plans, you should be aiming to get at least 90% savings per dollar you commit. If you're not hitting that, you might have chosen the wrong commitment level or the wrong service family.
And you mentioned thinking of these as investments.
Absolutely. You have to.
Yeah.
You should be targeting more than a 10% return on investment, or ROI.
Hmm.
But the key risk metric is the break-even point. You should only buy commitments that will pay for themselves within 9 months.
9 months, that's the magic number.
It is. Because if you can't break even that quickly, the risk of the technology changing from under you is just too high. You need to recoup that investment before the next big refactor happens.
And all of this has to be managed centrally.
Centrally with a holistic view. And you need to practice what's called commitment spreading. Don't buy all your commitments in January. Spread them out over the year so they expire at different times. It gives you more flexibility to react to changes in your forecast.
And all of these smaller metrics roll up into one ultimate KPI, right? The effective savings rate.
That's the one, the ESR. It basically tells you, after all is said and done, how much money are your rate optimization activities actually saving the company? High vacancy or a lot of on-demand usage will tank your ESR. It's the number you show to leadership.
So what does this all mean?
It means rate optimization is a strategic function that sits right at the intersection of engineering, finance, and procurement. It requires centralized coordination and a proactive strategy. This isn't just about chasing discounts. It's a continuous process of strategic financial investment, where you're constantly balancing the certainty of commitment against the flexibility of architecture. And this brings up a final, really important question for you to think about. Since we know the inputs to rate optimization have to include recommendations from workload optimization and sustainability, how do you, in good faith, justify buying a 3-year commitment for a resource when you know it's already on a roadmap to be right-sized or completely refactored in the next 12 months? That's the challenge. You have to manage that future change, or it will cost you.